Okay, so still in the first section here, we're finally getting to the point that I'm going to show you how you can prove that a limit exists, either by graph or algebra or however you want to do it. And this is where we look at the difference between a one-sided limit and a two-sided limit. Everything we've done so far has been a two-sided limit. Like if we said, let's take the limit as x approaches 0, we're looking at what happens as we get closer and closer to 0 from both sides. But we can also just look at a one-sided limit, like what's happening as we approach from the right or what's happening as we approach from the left. So if it's a right-handed limit, I don't know if you can read that or not. A right-handed limit, we say the limit as x approaches c from the positive. And if you can't see that, it's like x approaches c, and you put a little plus sign. That means coming from the right, coming from the positive side. When we read that, we don't say the limit as x approaches c from the positive. We usually say the limit as x approaches c from the right. And then a left-handed limit would be coming from the left side of your graph, and we say that as the limit as x approaches c from the left, and we use a little negative sign to show that. So if it has the little positive or negative sign with it, it means that you only look at what's happening to the graph on that side. You don't care what's happening on the other side. All right, and we're going to do some examples of this. This is a really important concept because this is how you prove that the limit itself, a two-sided limit coming from both the left and the right at the same time, exists. And so, this is kind of a lot of words here, but it says a function f of x has a limit as x approaches c if and only if the right hand and the left hand limits exist and are equal. And then we're going to write it in symbols. That little double arrow there is the symbol for if and only if. I don't know if you remember this from your fun days of geometry class, but if and only if means that the theorem is true both ways. Like you can read it as if this, then that, and you can also flip it around and say if this, then this. That's what if and only if means. You could just put IFF if you prefer over the double arrow. So the limit as x approaches c, if there's no plus or minus sign next to the c value, that means it's the two-sided limit. What's happening as I come from both the left and the right. It equals L if and only if the limit from the right equals L and the limit from the left equals L. So on your homework today, you're going to find some one-sided limits and use that to figure out if the two-sided limit exists. But I think there's also one that you have to explain how you know it. And this is what you want to say. How do you know the limit exists? You don't want to say, because I looked at the graph, or because I did this. They want you to say, because the left hand and the right hand equal the same, that's how I know the limit exists. The good news is a lot of this is just looking at a graph, so there's not a lot of work to show. It's just kind of a little understanding part. So I'm going to show you a graph, and I'm going to give you time to kind of sketch it. It doesn't have to be perfect, but that's what most of your homework is, so I think it's worthwhile drawing a graph on our notes. How you doing there, Alex? Alex found the cover of his calculator in his locker. We had a little discussion today of whether he felt he was responsible enough to keep track of it all year. And he says yes. I might have kind of blew up at Alex one day when he told me he lost the cover of his calculator.
Yeah.
I don't know who was in here that day, but I was like on my way to a meeting and I kind of like yelled at him, kind of meanly. I was really mad at you. I went to my meeting like fuming that you lost the linear calculator on like the 4th day of school. Apparently the 1st day of school. You just didn't report it to me. I don't remember. Maybe, yeah, because we had a meeting, yeah. Yeah, it was a day of the test. So, you don't have to make this perfect, but it is kind of important that you have that this little line segment starts at 3, and that this is up here, that open circle is on 4. That's kind of the important part that you get out of this. Oh my goodness. And then we're just going to find a bunch of limits. So we're going to start with the limit as x approaches 0 from the right of the function. So remember what a limit means. It's kind of, you have to go back to thinking about that now that we're looking at one-sided limits. We're saying what is happening as we're getting closer and closer to that point. Now that this is a one-sided limit, I just want to know what is happening, or what is the y value that's approaching as I'm coming from the right side of this graph. So as I get closer and closer to 0, here's 0, as I get closer and closer to 0, I would be on this line here, right? What would you say the limit is of that function? 0. Do you agree with that? The difference is, this one's not on here. What would you say the limit as x approaches 0 coming from the left would be? Kind of tricky here. We're following the graph, right? Like as I'm coming from the right, I kind of pick up on this graph on coming from the right, and I can follow it down and I say the points are getting closer and closer to 0. If I'm coming from the left here, are there any points on my graph at all on the left? There's no limit. This one's not even on here, but I'm going to add it here. The limit as x approaches 0 from the left, there's nothing here. Even though the point here at 0 is 0, because there's nothing coming from the left, there's no points to follow, you couldn't look at what's happening on the left side, we would say it doesn't exist. So, does not exist. I want to just say DNE. I'm okay with that. I just usually write does not exist. Or you could write no limit. That would work also. What about this one? The limit as x approaches 2 coming from the right. What do you think? If we're coming from the right, we're coming from this direction, yes? So coming from this direction, I'd be on this graph. And it just stops right there at 3, right? So is there anything happening at 2 when I'm coming from the right? Kind of tricky, right? Because if I'm coming from the right, I'm looking to the right of 2. Does that make sense? Like at 0, I'm looking at points to the right of 0, so that's why I'm on this little section of the graph, because I'm looking at points getting closer and closer to 0. If I'm looking at 2, I want to know what's happening as I get closer and closer to 2. There's nothing happening at 2 because my graph stops at 3. Does that make sense of where I'm coming from? So from the right means from the right of C. So I'm going to say I'll bring it better, I know it. So what if I say the limit as x approaches 2 coming from the west? That means look at points getting closer and closer to 2 coming from the west of 2. So points less than 2, what's happening? If I look to the left of 2 and I look to see what's happening, it's getting closer and closer to 4. Do you agree with that? So, what would be the limit as x approaches just 2? What does that mean when you see just 2 now instead of the right or the left? Yeah, it means coming from both sides. And we just said, in order for the limit to exist at C, which in this case is at 2, it has to be the same from both sides. So if you already did the right and the left, look up there. Are those the same? So definitely looking at the graph, coming from both sides, that's definitely not the same number. So there is no limit at 2 itself. Does that make sense on how you can tell if the limit exists or not? Final limit as x approaches 3 coming from the west. Coming from the right means to the right of 3. So if you were going to make a chart of this, you would pick points bigger than like 4, 5, 1. What would you say? 0, right? It's getting closer and closer to 0 as we come. Right. Does that make sense sometime doing that? So you're going to get some answers today, a lot more answers today than we've had in the past of the limit doesn't exist or there's no limit to that. This one's very similar. I think I took it right off the homework. This is a nice piecewise function that you don't love so much. Piecewise functions are the favorite thing to use for limits because you have to see if they're the same coming from both sides. On your homework, they're written just like this. It says c equals 2, and then they give you this function, 3 minus x when x is less than 2, 2 when x equals 2, and x over 2 when x is greater than 2. And then they have some things to do. And part A is we're going to draw the graph of f. So before we do anything else, we're going to graph this piecewise function. Down 1
And then at 2, it's the line f of x equals 2, which means a slope of 0, and it's just 2 itself. It's just a dot because it's only at x equals 2. At x equals 2, you're just going to make a dot on 2. We're going to see these a lot with piecewise functions because they want you to see like that hole in the graph and where it is. So don't get confused by that. At x equals 2, it's just the y value of 2. Does that make sense? And then greater than 2, I need to graph x over 2. So you could just pick some points over here. I just kind of always say, well, that would be a y-intercept of 0, up 1, over 2, up 1, let's see, that would be right there, up 1, over 2, up 1, would it just be like another line like that? Also, open circle right there. The c equals 2 has to do with part B. Part B says determine the limit as x approaches c from the right of the function and as x approaches c from the left. And they give us the c value, which, no surprise here, the c value is that point where it changes. So I'm going to write that up here because I didn't really leave myself any room to solve it. I'm going to find the limit as x approaches 2 from the right, and I'm going to find the limit as x approaches 2 from the left of my function. I'm not going to rewrite that. So as I'm coming from the right of 2, as I'm coming from this side, I'm going to look up at my graph, and I'm going to say what is the limit, or what is the y value that I'm getting closer and closer to as I approach 2. 1, right? Do you agree with that? And coming from the left of 2, that just means numbers less than 2 coming from the left. I'm now up here on this little part of my graph. And what value am I getting closer to? 1 again. Little bit of information. If you can figure out which line you are and you can do substitution, you could still do that. Like, coming from the right of 2, do you agree that would be when x is greater than 2? Could you do substitution and just plug 2 into this part of the equation? And look what you get. You get 1. Coming from the left of 2, do you agree that's when x is less than 2? Can you do substitution and say 3 minus 2 is also 1? You see how substitution can still work in a piecewise function? You just have to figure out which piece of the graph you're looking at. You don't have to, just trying to throw that out there. Now part C says, does the limit as x approaches c, which in this case is 2, exist? If so, what is it? If not, explain. And this is exactly worded like a problem on your homework. So what do you say? Does the limit exist? How do you know? Because the right and the left hand limit are the same thing. They both equal 1. So we know that our limit as x approaches c 2 has to also equal 1. Because the right hand and the left hand limit equal the same thing, that's how we know the limit also exists. And yes, you could look at it and use what we've been doing. That's how you prove it exists, is by explaining the right and the left hand limit. Right? That's the only other thing that we're missing today. I do have a homework sheet for you, and I think that you should do all the ones that aren't circled, which aren't that many. But basically, I'm going to give you the homework sheet, and you need to make sure that you've completed all of 2-1. So you have kind of jumped around and changed the assignment a lot. And so I'm going to just put here, finish 2-1 homework. Because we're done with 2-1 and we're moving on to 2-2 tomorrow. So I want to make sure that. Didn't you already do 64 the first day, I think? I think so. So that's what I have it written on there twice for some reason. But